Hi, Ben Pierce on the Roasted Tracker, and today I'd like to talk to you about how do you avoid objects colliding with each other in orbit around the Earth. This is actually a really huge problem, and it's been brought to light with the plans that SpaceX has to launch thousands of satellites into low Earth orbit. How are you going to keep all of these from colliding with each other? What exactly do you do to keep this from happening? How big of a problem is space junk? So we're going to talk about all of those issues. First of all, let's talk about why satellite collisions are a big deal. When something is in space, it stays in space for a long time. It could be forever. There's a piece of space junk that was launched in the early 50s that's still in orbit around the Earth. And depending on how high you go, it could last for quite a long time. Now, it really depends on the orbit. Their main region where we're worried about space junk is around low Earth orbit. Why is that? Well, there's not as much space, and there's a lot of satellites that are in that area. And things stay for a relatively long period of time. If you're below, say, 4 or 5, even 600 kilometers, you're going to re-enter the atmosphere pretty quickly, and it's not really that much of a concern. But if you get to be much beyond there, you could stay in space for hundreds of years. And that becomes an issue. At any one time, you're not very likely to run into issues. When I worked with a constellation of low Earth satellites, maybe one time per year, one of the satellites would approach some object that was of some concern, and we would have to do a thrust away from that situation to make sure that it wasn't going to collide. Okay, we've defined this issue. I should also say this. There's a lot of people who think that space junk is a problem everywhere. It's really not. A lot of people criticized Elon Musk for launching Starman into a very, very sun heliocentric orbit. Space junk is not a problem there. The only thing that we're worried about that far is if something that far will impact Earth. And quite frankly, if something like that impacted Earth, it wouldn't make a difference at all. It would burn up in the high atmosphere and give a nice little pretty fireball, but it's not really going to cause any kind of major issues. In fact, the bulk of the mass, the upper stage of the Falcon Heavy, is intended to break apart relatively easily, so it's really not that big of a deal. Geostationary orbit, it's a little bit of a concern. You don't want to have a dead spacecraft stay in geostationary orbit. That far out, objects are going to stay up there for basically forever, for thousands and thousands of years. To stay in perfect geostationary orbit, you really, really have to focus. You have to burn fuel because it will tend to oscillate up and down some and do some moving around. So it's probably not a huge concern, but what they actually do is they will burn into a slightly higher orbit that will keep them from colliding with some of the other objects. And one of the bigger concerns actually is radio frequency interference. And so by being higher, you're not going to have that kind of issue. So how is it that we actually do something about this? Well, the main thing that is important is to know where all of the objects are in the low Earth orbit in particular. And how do we figure that out? We basically use primarily radar. There are a number of different organizations that track this. The most well-known is known as the JSPOC, formerly known as JSPOC, the Combined Space Operations Center. Now, the Combined Space Operations Center operates between the space-type divisions of 4 different countries: the United States, United Kingdom, Canada, and Australia, the English-speaking allies, as they frequently work together. And what they do is they use their radars to track objects in space all over the place. And this will allow them to get some pretty great orbital information on everything that's out there. And if you're a spacecraft operator, you can register with them from any country, and they will send you alerts because it's in everyone's best interest to not have 2 objects collide. In 2008, 2 satellites collided with each other, and that caused all kinds of issues. Before then, the amount of objects of space junk was pretty small. There was also a Chinese anti-satellite test that happened about the same time frame. Between these three events, there is a massive increase in the number of objects that are tracked. This is very, very bad. We do not want this. And so these organizations work together. They have a website called SpaceTrack that's kind of their commercial type division, and they will release this information. They also do other things like tracking the spy satellites of other countries and other stuff like that they don't particularly release, but they try to release as much information as they can. Now, one of the things they will do is look to see if two of these objects are ever predicted to be close to each other. This is called a conjugation. And they'll send out one of these alerts. They can do it as much as 3 or 4 days in advance. There are some other organizations that also do these. The most famous is Celestrak, that has their own similar system. But however you get these notices, when you get them, it will show you about the time that they're expected to impact, and it will show you the velocity and how far apart they actually are. It's up to the operator to decide if they want to do something with this information, and each one will have a little bit of different criteria. The International Space Station, I believe, says that if there's a 1 in 10,000 chance of hitting a piece of space junk with the International Space Station, then they'll take avoidance maneuvers. And they might even do something that's a little bit further away in time. They might take some more drastic measures to be able to do this. Now, if all goes well, these events are discovered well in advance, but there's a lot of uncertainty in the tracking, and sometimes these events show up really, really quickly. I know personally there was one instance where I had maybe an hour or so that one of these popped up that met the criteria for a thrust, but we didn't really have any time to do it. Ideally, you probably want to do this thrust about 24 hours in advance because you can use a very, very small maneuver. 24 hours in advance, if you do even a thrust of, say, 1 centimeter per second, which is nothing, over the course of an entire day, that will be 86 meters. And you probably want to do a little bit further than that. 1 kilometer is what the distance that I have used in the past personally, and I think the ISS uses 5 kilometers as its desired thrust. But what you'll try to do is figure out if you need to do some kind of a thrusting maneuver for your own purposes anyways. Maybe you want to try to keep that satellite relative to the other satellites that are in your constellation or something like that. And you might do that thrust to get away from it, or you might need to go in a particular direction depending on coordination with other people. If this is a piece of space junk or a dead satellite or something like that, then you can do whatever you want to. If you're going against a live satellite, you need to talk to the other company that is doing this, because the last thing you want to do is have you both go in a particular direction that has you still potentially impacting at that same point in time. That would be awful. If you're both going in opposite directions, then that's great, but generally speaking, you want to have one of the two make the decision to thrust or not thrust and let the other one be. Bottom line is that space junk is a real serious issue. You want to do everything you can to keep a collision from happening because it's really, 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 really bad. Cannot stress that enough. Thank you guys much for joining me. Let me know whatever questions or comments you guys have, and until next time, keep on tracking. Take care.